Yeah. Okay. Hello, everyone. My name is Anton. I'm from Russia. I'm a front-end developer, and today I'm very, very glad to be here to stand on the stage, and I will try to make you interested. I work at SEMrush, and if you don't know who we are the guys who create cool analytic tools that makes the lives of digital marketing specialized easier. And I and my colleagues, we use JavaScript in our work, of course. And JavaScript is a really cool language. But sometimes JavaScript may surprise you, which is why there are currently many other technologies that can help us create large and complex web applications. And today, I'm going to talk to you about such technology, about ReasonML. Okay, let's go. Imagine what we are starting a new cool complex web apps. And if we take a JavaScript, we get a lot of great benefits out of the box. For example, we can create the first version of our app really, really quickly. And we also have a huge flexibility when writing our code. And if we make mistakes, then JavaScript will do its best to help us and execute a program. And all this sounds really cool. We are starting. We work hard and get results quickly. More and more features appear in the application, and the code base becomes bigger and bigger. And then, at one point in the console, we will see this. These are type errors, and I think that these errors are the most common when using JavaScript. And this is the price what we must pay for benefits which JavaScript gives us. And this is happening because JavaScript has a dynamic weak type system. Dynamic means that a programming language gets information about types at runtime, and weak means that a language may perform implicit type conversion at runtime. And if we mix these two rules, we will get runtime errors. And this is the problem. This is the problem because nowadays web apps can be really large and really complex. And in this case, JavaScript doesn't help. And as I said before, there are technologies that can help us to solve this problem. And some of them try to solve this problem to introduce static typing in JavaScript, while others are already languages with static typing and compilation in JavaScript. And now let's see what ReasonML is. If you look at the ReasonML website, we will see that ReasonML is not a new language. It is a new syntax and toolchain for the camel programming language. And thanks to this, ReasonML is very similar in appearance to JavaScript and can be used in the NPM ecosystem. And in a simplified scheme, this can be represented as follows. ReasonML and camel are two different syntaxes, and they can be converted to the same abstract syntax tree. And after that, we can compile it into bytecode or into native code, or, and this is our option, into JavaScript. And now let's see what benefits ReasonML can give us. ReasonML has a static strong type system, and this is the exact opposite of what we have in JavaScript. And in addition to the powerful type system, ReasonML also have a powerful type inference system. You can write code without annotations, and the compiler will infer types for you. Immutable data, functional programming, JavaScript-like syntax, JS ecosystem. ReasonML has it all. And everything that you know about how to create React apps, all your experience, all this you can use in ReasonML because you can create React application using Reason. Okay, now let's go in order. As I said before, ReasonML has a static, strong type system. Static means that a programming language gets information about types at compile time. And strong means that a language doesn't perform type conversion at compile time. And these two rules give us guarantees that there will be no runtime errors associated with types. And now let's see how types look in ReasonML. This is how we can annotate the code in the ReasonML, and overall it's very similar to how it works in other programming languages. But ReasonML allows you to write code without annotations, and at the same time, type coverage will still be full. And now to explain how this works and what benefits it can give us, I will make some comparisons with TypeScript, and I'll say right away that I'm not trying to say that TypeScript is worse or something like that. I just want to show how ReasonML works with types, and in comparison, it's easier to do. Let's write such code using TypeScript, and here the type person is defined and the function that creates it. And now let's see what signature TypeScript displays for the function. As you can see, getPerson function didn't associate the person type. TypeScript didn't associate the person type with the structure returned by the function. Okay, it's no problem. Let's try to help him a little and explicitly annotate the type returned by the function. And now TypeScript understands that the getPerson function returns the type person. But now we have another problem here. If you look at the function arguments, you will see type any. Unfortunately, even now, knowing which type is being returned, TypeScript cannot infer the types of function arguments. And honestly, in TypeScript, almost always need to write annotation, even in such an obvious situation. And now, the same example in ReasonML. There are type person and getPerson function, and let's see how ReasonML infers types here. As you can see, the function getPerson, the getPerson function takes two parameters. The first is a string type, and the second is an int type, and then returns the person type. This works because the compiler will analyze what exactly we wrote in the code, which operators or which functions were used here, and then infers the types needed to compile the code. In this case, ReasonML parses the getPerson function and sees what structure it returns. This structure is the same as the person type, which means that getPerson returns the person type. And in addition, ReasonML understands that function arguments are fields of type person. And that's how ReasonML inferred arguments types. And here it is. I think this is awesome. In ReasonML, there is no need to describe the obvious things. We just write the code, and the compiler will infer the types for us. But that's not all. There is one more example, and let's start in TypeScript. And there is a call function, and overall, this function can work correctly with any function with empty parameters, with empty arguments. And then we use this function to get the constants result and result2. And as you can see, both results are of type any. And now, if we want to solve this problem in TypeScript, we must use generic, which looks like this. And now in this case, types are inferred correctly. But if you have used TypeScript before, you know that sometimes generics can be really complex. And ReasonML can remove this complexity. Here is the same example in ReasonML, and let's look at the types. As we already know, the compiler infers the type based on what is written in the code. And in this case, all the compiler knows about the arguments of call function is that it's called as a function with empty parameters. So we can see this on the signature that the compiler infer. This is a function. This is a function that takes nothing. But the most interesting question here is, what does the function return? There are no obvious hints for an exact type definition, and the compiler infers the return time as a single quote A, and it's called type variable. You can think of it as a generics in TypeScript, and this means that you can use any type in this place, but it's not the same as any that is used in TypeScript. The type will be specified when we use the call function. And this is exactly what happens then the result and result2 types are output. And the main idea of this example is that we wrote the code that can work with various types in a language with a static, strong type system. And at the same time, we removed the complexity associated with generics. And I think that it's amazing. And we talked briefly about typing in ReasonML, and now let's talk about the syntax. As you saw in the previous slides, ReasonML is very similar to JavaScript, but of course there are some changes. And now I will show you a couple of the best features of the language. Let's see what happens here. The action type is very important construction called variant. Most data structures in the most programming language are about this and that. And a variant allows us to express this or that. And setBoth, setTitle, setYear, and reset are constructors, and they can contain one or several parameters or be without them. And now let's see how we can work with it. The reducer function takes action, which is a variant. And we use the switch expression to separate the logic into different cases. And is called pattern matching. Pattern matching is one of the best features of the language, and it's like a destructuring, but comes with even more help from the type system. To the left of the arrow, we describe a pattern, and to the right, what we want to do in this case. For example, if action is setBoth constructor, then the first parameter, which is a string, will be associated with the title variable, and the second parameter, which is an integer, will be associated with year variable. And then a new record will be returned. Besides, while matching the shape of your data, the type system warned of unhandled cases. For example, if we delete the setYear branch, we will see this warning. And now we know which cases we didn't handle. And this conditional aspect is what makes it pattern matching rather than plain destructuring. But these are not all possibilities that the pattern matching gives us. We can use it not only for variants. For example, this is how the solution of this bus problem in ReasonML looks like. And switch can take more than one parameter, and in fact, you can pass a tuple of parameters to it. And in our case, the first parameter is a reminder from dividing I by 3, and the second is a reminder from dividing I by 5. And then we describe the cases. If both are equal to 0, then this bus will return. If the first is 0 and the second is any number, then this will return. And if vice versa, the second is 0 and the first is any number, then bus will return. And in all our cases, the variable I will return. And now, one more thing. Let's try to swap the first and the second branches. And now let's look at the code carefully. The underscore in the first pattern means any value. And it turns out that 00 fits the first pattern, and which means that the second branch will never be executed. And in this case, the compiler tell us in this warning. This means that it checks not only for coverage of all cases for the input type, but also that all branches are reachable. And variants and pattern matching are really powerful features of the language, and they can be a very important factor in favor of using ReasonML. Okay, we talked about typing and talked about some language features, and now let's talk about React in ReasonML. I think if you have ever used React, then you can understand that what happens on the slide. We create a make function that takes props as arguments and returns a React element. And there are two unusual things here. The first, it's React component attribute, which is a syntactic sugar and is required for JavaScript interaction. And the second is React string function. This is an identity function that converts a string type to an React element type. And this is necessary because the language has strong typing and doesn't convert type at runtime. We must do it explicitly. And here's another example, and as you can see, we can use hooks here, and overall, it's all this is very similar to the React that we use in JavaScript. But that's not all. In ReasonML, we can use React components from JavaScript and vice versa. For example, suppose we have a library of React components, and we want to use this component from this library in ReasonML. And OK, let's try. It needs to create a new file with .re extension and write the binding that looks like this. And now all we need is specify the path to the React component in BS model attribute. It's like an import in JavaScript, and then we describe the types of props. And now the component can be used inside ReasonML, and this is how it looks like. I think everything is same as in JavaScript. Okay, since I've already showed the BS attributes like a BS model or React component, then let's say a few words about interacting with JavaScript. The BuckleScript attributes synthetic sugar explaining BuckleScript how to interact with JavaScript. You can find the full list of available attributes on the BuckleScript website, or you can check this link out. And I've already mentioned BuckleScript several times, so let's take a look at it. BuckleScript is a compiler from a camel ReasonML to clean, readable, and performant JavaScript code. For example, on the left side is the code that I wrote in ReasonML, and on the right side is what I got after compilation. The result variable will be obtained from the getResult function in ReasonML, but at compile time it will be computed, and in JavaScript we will immediately get the number. This means that the code what browser gets will not have function calls. The runtime is reduced, and it will have a positive effect on performance. And it seems to me it's really cool. Check this link out if you want to know more about how else BuckleScript improves performance on the final version of JavaScript code. And besides, there are more interesting things, but unfortunately, there is no time to talk in details. So if you are curious, you can look at the BuckleScript website. There is a list of, and here is a list of code editors that have plugins to support ReasonML code, and you can find links to these plugins on the ReasonML website, and it seems to me that everyone can find something for themselves in this list. And finally, here is a list of companies that already use ReasonML. And currently, ReasonML community are, of course, smaller than the Typescript or JavaScript communities, of course. But it's a very active and very friendly community, so join in. And I really hope that after the conference you will try ReasonML, because static typing together with such powerful type inference system will save you from many hours of debugging. So thank you very much.